Welcome everybody. Great to be here. Thanks for the invitation. I'm going to talk to you about natural language processing and how that can be used for museum data. Do you all hear me well? Is it? Yeah, clearly audible. Okay, good. So I'm from the University of Malta, and let's see what I want to talk to you about today. So, oh yeah, let me put a timer so you don't have to remind me all the time about the time. So that's stopwatch. Yeah, good. So I'll first start with talking about what natural language processing is, because I realize that maybe some of you don't really know what that is, and some of you might know, so I'm sorry for those that know already. And after that, I want to talk about what it can possibly do for museums. And of course, there it would be really nice to talk to you specialists of museum data, because that's not my expertise, but maybe in a dialogue we can get a bit further. I'll just talk to you about what I think we could do. Then I'll present two case studies, and these are just small studies that I've done quite recently, actually. One is about social media analysis, to try and explore the emotions that are directed towards museums in social media. And the last one is about how historical corpora can help us think more creatively. Good. So, what is natural language processing? Well, it is a subfield of artificial intelligence. And what makes us special is that we are concerned with language, hence the word language in there. And we're concerned with natural language, not programming languages, but the languages that we speak. Yeah, and we're interested in processing them, understanding them, and generating them. So there are two perspectives to our field, actually, and these are linked to two aims that people have when they're doing natural language processing. Some people say, and actually this is how it all started, our field, we want to create computational models to understand linguistic phenomena, and often people refer to the topic of that as computational linguistics. So these people are really theoretically driven, yeah? They want to make linguistic inquiries, so they're driven by linguistic inquiry. Then there's the other type of people, and I must say that these are now taking over the whole field, I think. And these are people that are more practically oriented. They want to create tools, yeah? They want to solve practical tasks, and for that they need to build models, and they apply these models onto language, and often these people are referred to as language technology people. They're practically oriented and application driven. So for the present talk, I will focus on the latter, because I think in museum data, most of the things that you're interested in is not so much in linguistic inquiry, but more into like what kind of tools can we use on our data. And the best way to understand what natural language processing is, I think, is by looking at some of these applications. If we're looking at the application-driven way, why not look at some of the applications? What can we do? So I'll start with a simple one, which is information extraction. And I think in the OntoText presentation just before, you saw already some examples of that. So what do we do there? We want to extract structured information from text that is non-structured. So there are various subtasks related to that. For example, named entity recognition, which is, as maybe, I don't know if you can see the example, is about trying to find parts in a text that are named entities. Yes, for example, persons, locations, dates, and you want to tag those. And you want to do that automatically. So we want to build models that look at these sentences and then say, oh, wait, there's a mention of a person and there's a mention of a location. Then, co-reference resolution is a very important next step, because if you're talking about US actor Johnny Depp that attends an official opening ceremony for the National Museum in Qatar, after that, when you're referring to the same person, you're not going to say all the time Johnny Depp, Johnny Depp, Johnny Depp. That's really not how we do things, right? We say he or the actor or something like that. And we want to link all these things so that we know that it's still about the same person. And this is what we do in co-reference resolution. And then we can go on with relation extraction and so on and so forth. So these were some applications. But these were maybe not applications where you immediately say like, oh yeah, I use that in my daily life. So I thought I'd give you also some examples of where NLP is involved in and what you use maybe daily, so you understand what we're doing. So for example, machine translation. I don't know if you use Google Translate sometimes when you have to, there's a message in Italian and you don't speak Italian, you're like, I'd like to know what this is about. You translate it automatically, yeah? These are models that we build. This is what we're working on in natural language processing. Because, as I always tell my mother, I'm doing things that have to do with computers and language, and somehow that kind of sits in her head, and I think she understands now, finally, after all those years, what I'm doing. Other things, question answering systems, so not like Google, where you type in just a word and keywords and you get some interesting documents, but you're asking a question, you get a real answer back. Those are question answering systems, and I worked on that during my PhD. Also digital assistants like Siri, maybe you use them when you talk to your phone and it talks back to you. Yeah, there's a lot of things involved in there. It has to understand what you're saying, and then it has to talk back to you in an appropriate way. It has to also know how to formulate your language, right? And also has to know about the grammar of it. So a lot of things are, NLP tasks are involved in creating digital assistants. Okay, so modern NLP methods work in what we call a data-driven fashion. So we need machine learning tools and we need data to learn from. Previously, actually, in the beginning of our field, people were mostly making rule-based systems. So there's a different approach there, right? So rule-based systems are, I know how things work and I'm going to write them down in code and then I'm going to apply them to data. Yeah, so it's more like an expert sitting down making rules. Data-driven systems, you have a machine learning method, and then what you need is a lot of data. And if possible, really what you would like is data that is what we call annotated. So it's annotated with the categories that you want to afterwards be able to predict yourself. So example that I gave previously with the named entities, you want to have lots of data where it's indicated that Johnny Depp is an actor and who was there, Victoria Beckham as a person, whatever. This kind of things. And then you can learn from it. The machine learning method will learn from your data. But this data is not cheap at all. I mean, you have to have people to sit down and say for everything here, like this is a location, this is a person. Yeah, I can imagine that that can be very costly. So let's move on to museums and look at the type of data that museums have. So I've looked around a little bit and I saw that data can come from their objects, from their collections, right? So data can also come from their day-to-day operational activities. And data can also come from the visitors, people that visited museums. Now, if this data is textual, there is a potential for NLP applications because we like to do things with textual data. So data from objects, we can have metadata, we can have from the operational activities, we can come up with marketing, there will be marketing strategies and communication that we can use. It's all textual information. Data from visitors, posts about museums on social media, for example, also textual. So I think there's a lot of things the data that museums have that is suitable to be used with NLP applications. As I said, models need annotated data and it's not cheap, but the nice thing about museums is that you have a lot of data that is some way looked at by people already. So there's metadata, there's all kinds of additional information that we should be able to harvest. So I think dialogue between museums and NLP specialists is really crucial so that we learn, like, what is your data like, what do we need? And so I'm really happy to be here, and I've already talked to some of you, and yes, I think we can get further when we talk together. Good, but I wanted to show you some examples so that you know what I've been doing and maybe get an idea of what NLP can do for museums. So the first thing I've done, and I've done that really very recently, was with a collaboration of a colleague from University of Stuttgart who was visiting us in Malta recently. So we looked at Twitter and tweets that people had directed towards museums, and we tried to analyze what kind of emotions we find in there. So what is emotion analysis? So next talk will be about sentiment analysis, and emotion analysis is quite similar to that. So in sentiment analysis, you try to classify utterances in either being positive or negative. Yeah? So this could be, for example, for Amazon products. Is a person positive or negative about it? Or a restaurant, positive or negative? With emotion analysis, you want to add an additional qualitative dimension. And what you want to do there is not just say positive or negative, but you want to say what type of emotion is really related mostly to the text that I'm looking at. For example, anger, fear, joy, disgust, surprise, and sadness are some of the mostly used emotions. So what did I do with my colleague, Roman? We selected tweets from the 20th till the 29th of March, so you can see that that's really recent. And we looked at a selection of museums, and we said, let's try and have a bit of a varied set. So we had the Van Gogh Museum, based in the Netherlands, about art, an established museum. Then there was something called the Disgusting Food Museum. I don't know if you've heard of it, but I thought it was interesting. It's about a different thing about food. It's quite new. It's based in Sweden. There's the Anne Frank House, based in the Netherlands, history, an established museum. Saatchi Gallery in the UK, contemporary art and established. And then, of course, I had to have something local. So I had the National Museum of Qatar, which we will be visiting tomorrow, I think so, about history, and had just opened. So some example tweets that, so our goal was to look at tweets and automatically say, what emotions do we find in there? So here are some examples of these tweets. So the first one says, Swedes don't have a sophisticated enough palate to appreciate Vegemite, but to put it in their disgusting food museum is an extreme cultural rebuke, and we should expel all their diplomats from the country. So, right? That's a strong opinion about Vegemite, and that it shouldn't be in the disgusting food museum, right? So yeah, what emotion would we link to that? I guess it's kind of anger, right? It's mostly anger, but it's also a bit funny, It's not that they're really that angry. Okay. Then the next one about the National Museum in Qatar. Congratulations, and proud for having such a wonderful and legacy for our identity. God bless the Emir, Qatar, and its people. Well, I think this is all joy, no? Somebody is very happy with this museum, and that's really great. And then about Anne Frank House. So here somebody says, Sammy, if I could make one recommendation, I'd really recommend the Anne Frank House. You have to queue to get in, but it's really worthwhile. It's quite humbling too. It's a bit hard, right? What do you say? It's joy, but then the humbling thing is also, giving another aspect to it. So it's not always that easy. So what did we do? We, of course, had to train our model. As I said, we need data, train, and then we can apply it to our target data, the museum data. Because I didn't have any training data for museum data, I tried to collect data that was most similar to it. So also tweets and, things that worked well in previous work. Then we used a classifier, in this case maximum entropy. We based it on bag of words features, which means very simple features, just looking at words. Yeah. And this is what comes out. I'm sorry that the colors don't really match very well, but we couldn't change that. So you see on the below, you see the Van Gogh Museum, the National Museum of Qatar, Saatchi, Anne Frank, and Disgusting Food. And then you see the emotions, yeah? So in this case, the pink is something where there's a strong correlation between these emotions for a particular museum. As you can see, the Disgusting Food Museum has a lot of negative emotions. So anger and sadness are really very apparent in the social media tweets that people have about this museum. There's also surprise, so maybe that can be seen as a positive thing. For Anne Frank, as we would expect also, people are not so positive, right? It's about a sad history element. So there's a lot of fear that we see there, but also disgust, yeah? And there's also sadness, but not as sad actually as a Disgusting Food Museum, which I thought was interesting. Also interesting that the Disgusting Food Museum doesn't have a lot of disgust actually in it. Okay. Then if we look at the positive emotions, we see that the most positive emotions are with the National Museum of Qatar. It's all joy, right? Joy is the most important feeling that we have there, and all the others are not very present. So I think that's probably related to the fact that it just opened. Everybody's very positive about it. Good. So that was, the first study that we did on this. What can we do with it? We can monitor emotions of visitors towards museums in real time. So, instead of, having somebody sit down and sift through all this data, you can let it just run and, have a kind of an alarm bell ring when people are very negative and you're like, oh, maybe I should change something in my collection. Something like that, I was thinking. You can compare to other museums and say, oh, look, the other museums in the same city are doing better than I am. What should I change? And then you can come up with tailored marketing campaigns and, maybe attract more visitors. So that was the first case study. So let's look also at the second case study. So the first case study was using, in terms of the data from museums, it was using that letter type of data, and the second one also. So it was looking at both the data that comes out of the institutional activities of museums, so marketing campaigns, because they're also part of Twitter, of course, because the museums themselves also tweet, and also about the visitors. What do they post in social media? Now, this one is about the content, it's more about the collections, the things that museums have. And, one of the things that you could find in general, in the cultural heritage are historical corpora. And I've used these to try and create tools that might drive creative thought in the future, not yet. So a small intermezzo here, because, I was writing these notes down and I was like, why am I, I'm getting very interested in creativity. Why is that? Well, in my field, NLP, we're mostly focused on analysis. There's a lot of work on analysis. There's people, analyzing the structure of a sentence. There's people analyzing what is the semantics of the sentence. It's all about analysis. And I think that's a little bit of a pity. So in this time of big data, a lot of people are focusing on finding what you're looking for. Yeah, they're all saying like, there's so much data, and we can't find what we're looking for. Google is doing its enormous best to make us find, type in something, and hooray, I found what I was looking for. That's great. But there's also something else. Don't we sometimes want to find what we didn't look for, but it's still relevant to us? Yeah, being inspired. I think big data is a unique opportunity to find things that you didn't think you would find, but you found them, and you're like, oh wow, yeah, didn't think of that. So we're kind of moving from big data to what we call cognitive computing, and some companies already picked this up. For example, IBM has come up with this IBM Chef that creates recipes by itself. Yeah? So it's all about doing things that we do, so trying to mimic the way the human brain works. And the human brain doesn't only analyze. I mean, it's part of what we do, and it's very important for us to survive. But we also create things. We talk to each other, we come up with new words, we come up with new ideas. So this is part of life, I think, and I'd like to put a bit more focus on that in our field, if possible. So before I move on to the creativity, I have to explain one linguistic phenomenon, and that's compounding. So compounding is the phenomenon of creating a novel word by putting two words together. And some examples of that, and I gathered these during my holidays, so you can figure out where I went on holidays. Yeah, who guesses it first gets a sweet from me. So trail mix was my first thing that I learned during the holidays. Then I always needed to bring a dry bag to keep my things dry. I saw some chipmunks. I needed bear spray. She does it. I needed mosquito spray as well. There were pit toilets, which wasn't the best part of my holidays. There were float planes. We did some tree-line hikes. You know it? Tell me. Canada, yes. We went on a camping trip on Canada, so that's why we also tasted the maple syrup. So what's interesting about compounds? So these are all examples of compounds. Well, compounds don't need to have they have a kind of a covert relation between the constituents. You don't see the relation, but you can make it up from the context. So if I say trail mix, and I showed you the picture, you were like, okay, there's trail, there's mix. Now, how do I connect the two? Well, it must be a mix that you eat during a trail, yeah? But if I didn't show you the picture, maybe you would have said a trail mix is probably a mix of different types of trails, one near the sea, one in the, it could be anything. So it's kind of flexible. And then a dry bag, I mean, if you didn't know what a dry bag was, you would say, oh, a dry bag, that's probably a bag that's dry, no? But it's actually not. It's often wet because the things inside, it needs to keep it dry. Spray and mosquitoes, we know that it's a spray to be used against mosquitoes, that you spray on you so you don't smell very nicely, so they stay away. The same for bears, although people have done this, but you shouldn't spray it on yourself in this case because it's really, painful. You should spray it towards the bear. So compounds are a very productive way of creating novel words. So by the age of 6, people, like children, can produce compounds, and 2-year-olds can even understand compounds, yeah? It's very flexible, and we don't need to worry about the relation. People will figure it out. There's a high level of underspecification, very flexible, and the combinatorial power, because you're combining things, is of course immense. So, what was our idea now that you know what compounds are? We wanted to try and look at historical data and try to kind of predict what kind of novel concepts people come up with. Yeah, so if you look at this is a screenshot from the Google Books Ngram Viewer. So maybe you know this tool. It's quite nice, I think, for people working in the humanities. You can type in a word or a compound, a combination of words, and see how often it was mentioned in books over time. So you see here that the word mobile phone wasn't mentioned very much in the beginning, and all of a sudden there's this spike, and everybody's talking about mobile phones. And this is, showing the success of this part of the technology, right? But how did people come up with the invention of mobile phones? Somebody must have thought at some point, mobile and phone, hey, yeah, let's do a mobile phone. How did that evolve, So I was thinking that perhaps by looking at other words that have some similarity with mobile phone, we could have kind of predicted that mobile phones would emerge, yeah? For example, there was a portable radio, and portable and mobile are linked, right? They're kind of not synonyms, but very much related. And radio is also a part of technological equipment. So yeah, by looking at what is already existing, you could combine it a bit in different ways and come up with new terms. And that's exactly what we did. We use the Google Books corpus, over 8 million words of books, over 8 million books and many more words, of course. And the time span goes from the 1500s to the 2008. So now, yeah, what do you do? How would you create novel compounds? Yeah, if I just asked you, like, you have to create a novel, you have to write a novel compound creator, what would you do? Well, one way to do that is like, oh, novel compound, I just take two random words, put them together, it's my novel compound. But of course, these would be very nonsensical most of the times, right? Just think of two words, put them together, you know, you're not often getting a really good compound out of that. So what we did is we tried to learn what good compounds are and what are the bad ones. So we use machine learning for that. So we had our corpus from the beginning. You know, we use only the first few decades for that. We trained a model on it and said, you know, here are some examples of good compounds from that part of the data. And here are some examples that we made up artificially. These are bad compounds. And now figure out how to build a model based on this data. And then, of course, we said, after we've done that, we're going to look at the last decade, the one that you haven't seen, the system hadn't seen at all, and we're going to see if those compounds that it comes up with are indeed good ones. Yeah? Are they found? So does it come up with mobile phone? Does it come up with these things that it should learn? Yeah? So what are the results here? Well, actually, around 80% of the novel concepts that the system created by itself are indeed found in the last decade of the corpus that it had never seen. So it did come up with a lot of sensible combinations. And some examples of novel concepts, so these are concepts that it had never seen before, but based on, you know, frequencies and combinations of things that it had seen before, it came up with these. It said, you know, I haven't seen this, but I guess that a Microsoft update is going to be something that people will do a lot in the future. And I guess it was right? So it might have seen other things that also needed updates that were very similar to Microsoft. And that's why it's decided, okay, I've seen other types of updates with other kinds of programs. Microsoft's update I didn't see, but I guess it's a good combination. The same for antibody library, it came up with that. And also culture loss, also something it hadn't seen before, but it thought that could be a good compound. So my idea to take this further is, you know, to help people come up with new ideas by, you know, providing them with tools, not just this tool, but all kinds of tools that help you think out of the box, you know, use data creatively, use it to inspire yourself. So that's just a very first step in that direction. And if you look at the types of data that museums have, I think they're ideal because museums are there to inspire people, right? Well, part of their mission is that. So I think, I mean, there's also visual data, and can you imagine if we bring together textual and visual data to create new things? I think it would be really a very nice and exciting topic. Good, so that's my talk. I'm sorry, 2 minutes over time, but good. I hope I gave you an idea of what natural language processing is. I was very brief in the beginning, but maybe you get a little bit of an idea of what it is. And also what it can do with and in collaboration with museums and with the data that museums have. And if any of the things that I talked about sparked your interest, please come and talk to me, send me a mail, and you know, hopefully we'll be in touch. Thanks for your attention.